Welcome viewers. In this video we will see the solved problem based on the resonance circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. See the statement of the problem. Determine the value of the capacitor C in order that the circuit in the diagram is at resonant at 6366 Hz. We need to find the capacitor value. Consider this circuit, the applied voltage E and frequency. In one branch, resistor and inductor is connected, 10 ohm, J5 ohm. In another branch, resistor and capacitor is connected, 12.5 ohm and capacitor. This C value we need to find. The condition given is the circuit is at the resonant condition. The resonant frequency also given 6366 Hz. Now we'll find the total admittance. The resonant condition means the reactive parts of admittance is 0. A plus JB means B equal to 0. That is the condition for resonance. That is inductive reactance equal to capacitive reactance, so got cancelled. Only resistance will be there. The reactive part is 0. So in order to go further, we will find the total admittance. In that we are going to equate the reactive part equal to 0 so that we can be able to find the C value. So the total admittance equal to Y1 plus Y2. Y1 means branch 1, Y2 is second branch. In the first branch we have resistor and inductor. Second branch resistor and capacitor. This admittance is nothing but reciprocal of the impedance. Both are reciprocal, impedance and admittance. So it can be written as 1 divided by Z1 plus 1 divided by Z2. Z1 is nothing but resistor plus inductor, 10 plus J5. Z2 is second branch, resistor and capacitor, 12.5 minus JXC. Right? So this C value not available, so it is written JXC. Right? Now we can go for the further simplification. Now this is the total impedance. The J is available in the denominator. In order to bring into numerator, it is multiplied and divided by the complex conjugate, so that will brought the J term in the numerator. So the complex conjugate of 10 plus J5 is 10 minus J5. So it is multiplied and divided. Similarly, 12.5 minus JXC, complex conjugate is 12.5 plus JXC, multiplied and divided. So here while simplifying, this 10 minus J5 is written. So this term is nothing but A plus B into A minus B. A is 10, B is J5. A plus B into A minus B is nothing but A square minus B square. A is 10, 10 square minus B is J5, J5 square. Similarly this term 12.5 JXC is written here. This is also A minus B into A plus B. It's nothing but A square minus B square. A is 12.5, B is JXC. Right. Now we'll square the term. 10 square is 100. J5 square is 25 J square. 12.5 square is 156.25 minus J square XC square. We know that J square value is minus 1. Here also J square value is substituted minus 1. So minus 25 into minus 1 it become plus. So here also minus into minus become plus. Right? The term become the plus. So it is written 100 plus 25, 156.25 plus JXC square. Right. Now so this 100 minus 25 is 125. Now we'll split the terms. 10 divided by 125. Right. Minus J into 5 divided by 25. These terms are splitted. Similarly 125 divided by this term plus JXC divided by this term. Now we see this is these two are real terms. The term contained J is the imaginary term, that is the reactive part. Right. Now these two terms are written separately, that is simplified. 10 divided by 125 is 0.08 minus 5 by 125 plus these two terms are written. Now we'll combine these two terms, first term and third term, that is the real term. Second and fourth is the imaginary term. Now we'll combine. Now these two terms are combined together. These two are the real term. This is the imaginary term. So the condition given is resonance. Under resonance, the reactive part of Y is equal to 0. That is, this term is equal to 0. That is capacitive inductance and reactive inductive reactance are got cancelled, so that this reactant part is 0. So that is the condition given in the problem. So Xc divided by 156.25 plus Xc square minus 5 by 120 equal to 0. Bring this term that side, so it become plus 5 by 125. So Xc divided by this term, so 5 divided by 125 is 1 by 25. This goes with the 25 times. Now we'll cross multiply this. We'll cross multiply the terms for the further simplification. So it become 25 Xc equal to this term 156.25 plus Xc square. Bring this 25 Xc that side, so that it become minus 25 Xc. So that is equal to 0. So it can be written as Xc square minus 25 Xc plus 156.25 Xc equal to 0. This is nothing but a quadratic equation. So this can be written as Xc minus 12.5 the whole square. A minus B the whole square is A square plus B square minus 2 into A into B. Based on the formula we can write. So X minus 12.5 equal to 0. So Xc equal to 12.5. So from the given condition we got the Xc value. But what we need is the capacitor value. Capacitor value is needed. So Xc is the one more formula 1 divided by 2 pi F naught C. So here what we need is C. So interchange this term. Bring this term this side and bring the Xc that side in the denominator. So C equal to 1 divided by 2 pi F naught into Xc. So 1 divided by 2 into pi into this frequency is given, resonant frequency 6366 into 12.5. What we calculated Xc is 12.5. So while simplifying we got 2 into 10 to the power minus 6 farad. That is nothing but 2 microfarad. So finally we calculated the capacitor value under the resonant condition by equating the impedance, admittance term, reactive part of admittance equated to 0, so that we got Xc. From Xc we calculated the C value. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.